All right, we are now looking at our notes for the advanced section of the test for KC7. So a lot of these are just word problems and just going a little more in depth into different scenarios you can solve when you have when you use trig ratios and trig equations. So in example 1, a surveyor stands 200 feet from a building to measure its height. Okay. So here's my building. Here's my little surveyor. Okay. The angle of elevation to the top of the building is 35 degrees. How tall is the building if the surveyor's instrument is 4 feet off the ground? Okay, so now we're going a little more in depth because now we're taking it into account. When I look up at a building, my eyes aren't where my feet are. My eyes aren't on the ground. All right, so if I'm looking through a piece of equipment, my eyes are up here. Okay, so I am 4 feet tall, or my eyes are 4 feet tall, or the equipment's 4 feet tall. Okay, and this angle of elevation is 35 degrees. I'm 200 feet from the building, so if you're measuring from where my eyes are or where my feet are, both of those are 200. So that doesn't make that big of an impact. But I do have a 4 over here, right? This little piece here is equal to this little piece here, the height of my equipment. Okay. So I want to solve for the height. So I am going to solve for this opposite side here. Okay. So I have my hypotenuse, the opposite, and the adjacent side. Okay. So I'm going to be using tangent because I have the opposite and the adjacent. So tangent of theta equals O over A. Tangent of 35 degrees equals x over 200. I put it over 1. I have x equals 200 times the tangent of 35. 200 times tangent of 35 is, that's not what I wanted. Hold on, let me make sure. I can just expand it. No? Okay. Tangent 35. And I get 140 feet. Alright, but that's not the total height of the building. Alright, the building is from the ground all the way up. So just like we did before, I have to add. Okay, so total height equals the 140 feet we found plus the 4 feet my instrument is off the ground. So the total height of the building is really 144 feet. Okay. Let's look at another example like this. A person whose eyes are 5 feet above the ground is standing on the runway of an airport 100 feet from the control tower. That person observes an air controller at the window of the 132-foot tower. What is the angle of elevation? Okay. This one, again, is kind of tricky, so let's draw it. Okay. I have a person. They're 5 feet tall. They're looking at our lovely control tower. Okay, so he's looking at a person up here. The tower is a total of 132 feet tall. And he's 100 feet from the control tower. I'm trying to find my angle of elevation. Okay. Well, again, this is also, this is also 5 feet. So what's this here? It's 132 minus 5. This little piece, right, what I can see straight ahead to the top, is only 127. It's 132 minus 5. Okay. So again, I have my hypotenuse. I don't know why else I did. Right. The opposite side and the adjacent side. Okay, and I'm using O and A. So that would be tangent. So tangent of theta equals the opposite over the adjacent. So tangent of x equals 127 out of 100. Or 127 over 100. Okay. So x equals the inverse tangent of 127 over 100. And our inverse tangent is 51.8. Oh, I can't write today. 51.8 degrees. Okay. So again, all these are showing is that when you get a little more into it, you have to take into account how high your eyes are off the ground, because you're always going from your line of sight. All right, let's look at example 3. 2 observers on the ground are looking up at the top of the same tree from 2 different points on the horizontal ground. Okay, so I'm going to draw that. I have person 1, person 2, big tree. Okay? So these 2 people are looking to the top of this tree along the ground here. Okay? After all we just said, we're going to pretend that we're not going to worry about their eyes, because this is their eyes. But we're looking up from this person and this person. We're going to not put their height into account for this problem. Okay? The first observer is 83 feet away from the base of the tree. Okay? So my first observer here is 83 feet away and looks up at an angle of elevation of 58 degrees. Okay. The second observer is standing only 46 feet. Sorry, I had that wrong. The second observer is standing only 46 feet away from the base of the tree. Okay, so the second observer is closer. So the first observer is 83 feet away. With 58 degrees. Why? And then the second observer is only 46 feet away from the base of the tree. Alright, so the first thing I'm going to do is find out how tall is the tree to the nearest foot. So my first thing I'm solving for is the height of the tree. Well, the height of the tree is over here, so that's x. So I have an angle and this length here, so I'm going to be using this bigger triangle. Okay. If you look, I have the opposite side and the adjacent side, so I'm just using tangent. So tangent of theta equals opposite over adjacent. So tangent of 58 degrees equals x over 83. Okay, over 1. X equals 83 times the tangent of 58 degrees. So x equals 1 132.8. Okay, so the height of my tree is 132.8 feet. Then our second question is then, at what angle of elevation must the second observer look up to the top of the tree? Okay, so this is going to be very similar, just kind of flip-flopped. All right, I want to find my angle here. Well, again, I have my opposite side, but now I'm using 46 as my adjacent side, so I'm going to be using the littler triangle. Okay, so I'm still using opposite over adjacent, I'm still using tangent. So tangent of theta equals opposite over adjacent. So tangent of x, right, I'm solving for the angle, equals 132.8, right, that height is what I'm using, over 46. Since I'm solving for the angle, x equals the inverse tangent of 132.8 divided by 46. So the inverse tangent of that is 70.9. Or we'll just round up to 71 degrees. Why not? Okay. So he's looking up an angle of 71 degrees, which makes sense. As you move closer to something, I think if you're walking towards a building, you have to look up more and more and more to see the top. Okay, so as the closer person should have a larger angle. All right, we have one more problem, which is very similar to that last one we did. So a person starts out 17 miles from the base of a tall mountain and looks up at a 4-degree angle of elevation to the top of the mountain. Okay, so I'm going to draw that. My person's here. Maybe. Person. And my mountain's going to be over here. Mountain. I can't spell mountain, I guess. So this person is 17 miles away. And they're looking up at an angle of 4 degrees. They move 12 miles closer. So I'm actually going to move this 17 down. This whole thing is 17. So my person now walks 12 miles closer. Try that again. Doesn't like me making points. Okay, so this red line is 12. And then what will their angle of elevation be when they look at the top? So again, I'm looking for x. Well, using what I know for the first set, I can find the height of the mountain. Okay, so I can't go right, when with a problem like this, I can't start right into what x is. Okay? It's like the other problem. I still have to figure out some other things first. Okay? What other things do I need to know? Well, if I want to figure out this angle, I need to know some sides of that triangle. Okay? That didn't change colors. Sorry, guys. It's orange. So I need to know, the easiest sides I think for me to know is know here, because if I have 12 here and this whole thing is 17, I already know this is 5. Okay, so that one was easy. I mean, that'll always be that easy. The other thing I need to know is the height of the mountain. So I'm going to put a y there. Well, I can solve for that y, right? I know that y is also the opposite side of my big triangle, and I have the adjacent side, and I have that angle. So again, using tangent, tangent of 14 degrees equals y over 17. Putting it over 1, right, y times 1 is y. And then I have 17 times the tangent of 14 degrees. So 17 times tangent of 14 is 4.2. So our mountain is 4.2 miles tall. Now that I know that, I can do the same problem we just did before. Now I can figure out this angle, right? That's still the opposite side, and then I have that adjacent side. Okay. So tangent, again, of theta equals opposite over adjacent. Tangent of x equals, I didn't write it, tangent of x equals, opposite side is 4.2 over 5. So x equals the inverse tangent of 4.2 over 5, which is 40 degrees. So you go from barely looking up to see the mountain to when you walk forward, you have to look up a lot to see the mountain. Okay, so x equals 40 degrees. All right, that's it for your notes. This question, your first question in your advanced task is very similar, but you will run into a few things that might be tricky. Feel free to ask questions, but it is set up similarly. And then for number 2, I am just going to walk through and draw the picture real quick. Okay, I meant to put the picture on there, and for some reason it didn't get on there. So 2 observers, located at point A and B in the diagram, right, which is confusing, are watching a climber on the opposite face of a chasm. So basically, you have this chasm, so like 2 cliffs facing each other. You're going to have person A on top, and person B is on bottom. Okay? And they're watching someone on the opposite side, over here, climb. Okay, so this is my climber. So person A is looking down, person B is looking up. Okay? And our chasm is 81 feet wide. Remember then, he's looking down at an angle of depression of 20 degrees. So that angle is going to be here. Observer B sees the climber at an angle of elevation of 51 degrees. Okay. Then there is no question. Sorry, guys. And then it's asking how tall, lots of issues with this one. How tall is the chasm? Okay, so it's just looking for this total height going straight up. And that's it. Go ahead and work on your activity so we can do that advanced task.